But it's really important that they hear about it from you. Because you were about to say that when this time last year you heard from other kids about it. That's why. Every year for about 15 years I've been doing this to try to combat grown-up scheduling kids without the students choosing. The best thing about this class is that most of you actually had to ask for it. So you're kind of here on purpose. That's a big deal. That's a big deal. I'd really like you to tell other kids if it's a good fit for them or if it's a bad fit for them or whatever. Are there questions about that? By the way, speaking of course signups, that zero period class is freaking rad. Just say it. Yeah.
What class were we supposed to have signed up for our courses in?
English.
English? You were absent that day?
I never seen it.
You're senior?
No.
She doesn't get to go to next year.
Nice. Okay. Everybody just did. Don't tell Sadie we're signing up for classes today. Oh, you wouldn't want to go. Don't worry about it. Anything else about course signups next year? Other science classes? Anything else? Who are the seniors? Next. Silence. Solar house plans are due a week from Thursday. That's pretty tight. I've had like 3 or 4 students meet me during seminar to look over their papers. I've had like 2 students communicate via like lengthy and detailed text chains to like look over their plans. And I've had like radio silence from everybody else, which is fine. We cannot move on with life unless we talk about the coronavirus, though. So the coronavirus seems to be one of the deadliest pulmonary infections on the market today. It is apparently extremely contagious. So first we realized that it can be passed from person to person, then we realized that it can be passed from person to person through secondary contact, like you touch something and another person touches that. Now it appears that it may be transmitted before you're symptomatic, so you wouldn't know that you have it when somebody else gets it from you. That's actually a really scary variable in pandemics. We have an international epidemic, so any day this week we'll start to discuss it as a pandemic. The World Health Organization labeled it a global health crisis last Friday. And now, a global health emergency, I can't remember which. And now the CDC and I believe the US State Department are like raising the categorization so it'll affect travel to and from the United States. It might have been somebody in this class who mentioned that China was going to build a hospital in 9 days. And I was like, no, that's fake news. And first of all, that was apparently not fake news. Second of all, they just did. Like, they literally will be like fully operational tomorrow. It took me like 15 days to build like a picket fence. It took like 3 months to pour a foundation for my rear patio. Hand somewhere? Yeah.
How many people like died from it, and like what's the closest case of it to us?
Toledo.
Oh.
Michelle Jaffe, we should all pretend that Michelle Jaffe has the
She's really
coronavirus.
scared about it. She like talks about it all the time. It's so sad.
There's below a 2% mortality rate.
What?
There's below a 2% mortality rate.
It's actually 3%.
Oh.
Yeah, except
Oh.
that's not counting all the cases that are possibly coronavirus that people just thought they had the flu or they're not symptomatic and they didn't die, so it's like an overestimate.
Fine. Bubonic plague with modern treatment is way less than 3%.
Yeah, but the bubonic plague has been around for a hot minute, so they decided they found ways to like combat it. So like the coronavirus, they just need a little bit more time to
Yep,
figure it out.
Yep. It's entirely
Yeah, I'm
possible.
not opening that.
It's entirely
Plague, yeah.
It's entirely possible that this will be better dealt with, but I mean to say that it's about 300 times worse than the worst seasonal flu in terms of mortality. Like 3% is actually really high. Separately, yeah, you're right. It's only 3%, and so like pretty much anybody who's otherwise healthy has really good odds.
Yeah, because doesn't it?
Like you're much more likely to have much bigger problems.
Because it like affects the respiratory system a lot, I think, right? And since it started in China where the air quality is pretty bad, like the mortality there is low.
I don't know if that's relevant, because not all parts of China have bad air quality. Yeah.
Isn't there something though that it's only sort of killing people with like compromised immune systems or who are?
That's just generally true of any respiratory illness.
Yeah, so then people who shouldn't exactly be scared to death about it.
Right, yeah. I mean, the whole thing is like 3%'s not that bad. Like that just means you got to be better than 96%. They have to be as bad as 96% of the people around you. Like your odds individually are pretty spectacular because you're like teenagers and like, all right, like physically speaking, most of you are totally fine. And even for a geezer like me, I'm probably better than those worst 3%. Like I don't have to get too far off the bottom of the barrel. But yeah, I mean, I just feel like it's an interesting moment. This is one of the fastest spreading, deadliest diseases of your lifetime.
What about Ebola?
Yeah, so that's a worse one. I didn't say it was the worst.
But we survived. Ebola.
Interesting thing about Ebola is it kills faster than it spreads on average.
That's not smart.
No, so
it
it,
contains itself.
evolutionarily speaking, that's exactly the deal, that diseases have evolved to not be super deadly, because if they're super deadly, then diseases put themselves out of business. You know, they kill all their people before their people can spread the disease for them.
Good.
Yeah, so I don't know, it's an exciting moment, I guess.
Exciting.
Two things come to mind.
Yes.
Two things come to mind. One of them is, remember what I told you about the diseases of the future that are the biggest threat,
No?
and how similar this is?
Yeah.
Considering that it was zoogenic, considering that human migratory behavior played a big difference in the pandemic nature of this one.
It's literally the plot of that movie.
It's
Yeah,
literally the
it's
plot of that
so
movie.
weird.
Yes! And remember that movie was hyped before I showed it to you because of its tremendous consultation with the Centers for Disease Control forecasting mass pandemic in the future.
Alright.
So it was scientifically prescient when they made Contagion, and now it's actually happening. To me, this is like a big like, wow, science was right kind of thing. I'm not trying to like stress you out. Like, I guess a lot of you don't realize just how special we are. Like, we're like the luckiest, healthiest humans on the planet. Like, we're on the right side of the wall. Oh, one last thing. Amazing all over the place hate crimes against Asian people or even people who just look Asian.
So you're saying hate crimes are amazing?
Amazing.
So, no, there have been like a couple of violent altercations in Chinatown, and like people of Asian descent say that it's getting harder to like sell food and stuff. And there's all these like mean memes on the internet about like food xenophobia. And so like you eat bats, like people just being mean to each other about, like different food cultures. I don't know. I find this all very interesting. Because I'm a nerd.
Do they know how it started?
Yeah.
Snake.
Well, it is believed that it started at a open air market where people buy what I in this class previously described as bush meat. Like wild foods.
Meat found in bushes.
Like non-traditional protein sources, like all right. All right. Are we done? Nobody? Coronavirus? Okay. Then let's do some other stuff. Take out your nuclear papers. You'll give me some notes today. I'm going to spend 3 days explaining how that spins a turbine.
Exciting.
What notes are we taking out?
Nuclear stuff. What is that, 6.4?
Should we just start one?
6.5.
6.5 then.
Should we start a new page for this?
I don't care.
No, I have one left. Oh, sweet. I only have the one left, That's the only time.
I literally have one right here for you.
You want us to draw that, right?
No.
Oh, okay.
Okay, stop. Liam, are we streaming?
Yeah.
Thanks. Children, the College Board basically every single year asks a number of questions about nuclear energy. And if you want to discuss a nuclear power plant, you kind of need to know some nuclear physics, and that's not generally easy for high school kids. By the way, it's not easy for me either. I'm not an expert on this. Fun fact, my father, on the other hand, is a nuclear physicist. Weird thing.
You said that you found out yesterday that you.
No, he hasn't worked, he worked in a nuclear power plant when I was young. He was actually an early computer programmer. So he's like a physicist mathematician, and he went to work there because of his science background, and that was when early computing was starting, when people would punch holes in paper and use paper strips to program computers. And now he just kind of went the the computer programming route and not the nuclear part. So strangely, when we do this, I realize that I could talk to my dad about this, but he's totally in a different world now. Anyhow, this you might remember from before: Bohr, helium, Bohr, hydrogen. In order to discuss a nuclear power plant, we're going to have to discuss some nuclear reactions, nuclear chemistry stuff. And in order to do that, we got to get some real basics that probably all start from things you've already learned in chemistry. So at some point, you're going to be like, yes, this looks familiar, and oh, that might have been new. And then it's going to hopefully get into some new stuff by the bell. I really do have a 3-day plan for this. Ready? I'm going to show you the parts I need you to write after I talk about them. So I'm going to talk about this section and then you can write it. Please look up. The Bohr atomic model says nucleus has neutrons and protons with electrons buzzing around. Bohr says rings, we know better. Fine. Neutrons, protons, and electrons are neutral, positive, and negative. Those numbers are roughly proportional in the common elements. Roughly proportional. Like carbon has 6 of these and 6 of those and 6 of those. Same. Neon has like 10 and 10 and 10. Most of the smaller electrons are roughly the same number of protons and neutrons and electrons. Now, things happen where through a variety of forces, you can change the number of electrons, much more rarely the number of protons, and quite often even on our planet, the number of neutrons. Here's what happens. When you change the number of electrons, which is relatively straightforward, that just affects the charge of the atom. These are ionic changes. How many of you have heard of ions and you remembered that it was about the charge and positive is missing an electron and negative has an extra electron? Easy. The number of protons doesn't really change. On our planet, that's very rare. Please look up, the number of protons affects the atomic number, which just says which element it is. So palladium is number 46. It has 46 protons. That's why it's palladium. A good way to think about this is the element is a word for the number of protons. Anything with 79 protons is called gold because the only thing that makes it gold is 79 protons. Okay with this concept? That proton is just the element and that's okay. And finally, neutrons can actually occur in different numbers. You can have extra or fewer. That would affect the atomic mass. Those are called isotopes. Some of which are unstable. We're going to come back to that. Before you ask any questions, put this on your paper because I'd like you to draw other things around that in a minute. I don't know. It's just like an intro to nuclear stuff. Doesn't really get a question. Like honestly, the kids in AP Chem probably don't need this. Probably. Who's in AP Chem? Anybody in AP Chem?
They didn't offer this.
Yeah, they don't have it.
There's no AP Chem this year?
No.
That's brutal. That's not up to her. She would have loved to do it. I'm sure that she was the most bummed about it.
No, it's because no one wanted to do the classes.
Yeah, she was
Well,
really.
Oh,
Sent
I
out.
don't know. But
There's a rumor that someone sent out emails about how it's so hard and then no one signed up for it.
Something like
She told me that they didn't want to give her the class because it's only one class and she's only working part-time now. So they were like, that's what Mrs. Rivera told me. She could be lying, we don't know. I don't know, I don't know.
Nice.
I have great sympathy for teachers and the social element of how their jobs are discussed by students. I'll tell you that master scheduling is really complicated. Very few people actually know why any of that happens.
the wet things weird everybody.
Well, what?
The wet things weird everybody.
Oh, cool. I hate some food.
Because it's further off.
Just this part, okay?
Which power plant is that?
I don't remember. It's not in the US. Electrons, negative, just affects the charge of the atom. Those change all the time. If you could change the number of protons, that would change which element it is. That's what alchemy is. Like changing one element into another. You would need to change the number of protons. And on our planet, that's very, very rare.
You mean like naturally occurring or at all?
At all. Like as hard as we try, we can make it happen with tremendous effort. One place is a nuclear reactor. Outside of a nuclear reactor, it's even more rare. That happens in outer space, like inside of stars or something. I don't know. Yeah.
But isn't it that like when radioactive elements are like losing their radioactivity, they are like becoming like less radioactive, obviously, and so they go like down the periodic table.
Mm-hmm.
So
And that's
they are-
actually what radioactive
It's
decay is. It's falling apart.
Yeah.
And so in the decay chain of the radioactive ingredients, they're the ones that change. So the only ones that do this naturally without human interference are ones that are inherently radioactive to begin
Yeah.
with.
So if you had some protons, you kind of just like shot them into an atom, you could change the element.
That was two really big ifs, but yes.
Yes, obviously if.
Yeah, yeah, so if and if, then yeah. Yeah, absolutely. You could just take, you could take lead and bang out 3 protons and you'd make it into gold. If only.
There was like a period of time when people worked really hard on trying to do that,
Uh-huh.
right?
Yeah, alchemy, that thing I was talking about.
No, yeah, I know, but like
Yeah.
there was a time when alchemy was like
Yeah.
a big thing.
Yeah, yes.
Isn't like shooting stuff at each other just particle accelerators?
Yeah. So, I don't know if particle accelerators are protons though. I was under the impression that they're neutrons, but I don't know jack about diddly. Particle accelerators are kind of right up there with unicorns for me. I don't believe it when I see it, bro.
Particle accelerators are electrons, right?
Hey, they're electrons.
Yeah.
Yeah.
So they weigh the least, so they can move the fastest.
If you said that they are fairy dust, I'd be like, yes. David said it very convincingly. They are fairy dust. I'd like to explore. I'd like to explore the periodic table with those few things that I've just told you so far. And it's kind of tough to see what's up there. So I want to use this as an example. You don't need to draw it yet, but I want to do a little bit of math here, and I want to explain what the math is that we're looking at. So neon has a 10 up there and a 20.179 down there. You don't have to memorize those numbers. You probably don't even need to write them down. If you don't believe me, you can, what was it, 10. You can look this up on your own. There it is, neon. 10 at the top, 20.179 at the bottom left. So I just copied that from here, from there here. And I want to remind you that the atomic number is just the number of protons. So we know that in the nucleus of neon, we'll always have 10 protons. That's the thing that makes it neon. And this number down there, now that we can talk about it, is called the atomic mass, which is the number of protons, the number of neutrons, and the number of electrons, given that a neutron weighs 1 atomic mass unit, protons weigh 1 atomic mass unit, and electrons weigh a teeny little bit. Again, you've probably heard this all in chemistry before, but we're about to get to something a little bit interesting. First, notice that in neon, a little bit over 20 minus 10 means that there's 10 neutrons. 10 plus 10 makes 20, 20, okay. So it's 10 protons because it's neon, and that must be on average 10 neutrons. Funny thing is, if you take the atomic weight of all the electrons, it doesn't add up to 0.179. 10 electrons weighs a lot less than that. So what's interesting is atomic mass is an average, so there must be some neons that weigh more than 10 plus 10. We're just going to leave that out there for now. We're going to come back to this in about 15 minutes. Notice for now, the other thing I wanted to point out. We'll come back to the weight thing in a minute. But notice that 10 and 10, those are proportional. If you go to carbon, 6 protons, it weighs 12. 6 plus 6 equals 12. Proportional number, 6 protons, 6 neutrons, hooray. Yo, bro.
So does the atomic mass of an element like approximately increase by 2?
Yeah.
Mass units every
So the
time?
atomic mass of the elements increases by 2 because you know you're adding 1 proton and the proportional 1 neutron. For a while. So these tend to go up by about 2. 7, 9, 11, 12, 14, 16, 19, 20. That's about 2. But I'd like everybody to consider something and then I'll show you the example. Watch me, please. As we go through the larger and larger elements, that proportion of protons to neutrons falls apart and they start to gain extra neutrons, just junk, just baggage. Nuclear physicists can draw all of the forces, electromagnetic and gravitational, inside of the nucleus. That's what nuclear physics is understanding the forces inside of a nucleus. And sometimes they just kind of end up in these weird shapes that can just hold an extra neutron, just junk. One way to think about this is like the average pickup truck has some random junk floating around in it, more than the average junk of an average motorcycle. My motorcycle's average. I've got a little cargo box in the back. There's probably like 2 crumpled receipts and a pencil. Like not a lot of cargo, so not a lot of space for junk. My Tacoma, I've got an unbelievable volume of random junk in my Tacoma. I found a dead rat. I found
Oh, it's a snack.
my old friend's climbing shoes. I found a broken jar of blueberry jam. I found a radioactive compass when I was crossing the border back when we went to Baja. You might remember, I was with a homie who's Syrian.
Yeah.
Maybe you didn't know that about him. His name is Humam. You might remember, and he's Syrian. He was the chef guy. And that was in the middle of the Syrian refugee crisis. And I had my big dirty guy beard and like flaky skin everywhere. And we were like, my sketchy ass truck was towing this sketchy ass dirty boat that just been on dirt roads, so it was all dusty. And I get to the border crossing, and we're all like sunburned and like been out of the country for 7 days, and everything was dirty and smelled horrible. And we set off all the radioactivity detectors, and they wouldn't let us in. And they were like, "Sir, where are you from?" And I was like, "I'm American, but I'm from another country." And then they look at the other guy, they're like, "Sir, what about you?" He's like, "I'm Syrian." And they're like, "Get out, get out." And so we had to like get out, and they searched the whole car. And my friend Megan Ball had her grandfather's compass from World War I in the back, and she like put it in a little side pocket in my Tacoma, and it was forgotten for like a decade until the radioactivity detectors found it. Because back in World War I, they used iridium for the glow-in-the-dark needles. So literally, I found a dirty bomb in my car. The point of the story is, as you have more random little pockets, you pick up more random little trash. Hey. In other words, as a nucleus becomes larger, on average, there are more and more disproportionate bonus neutrons. This is a pattern that I wanted to point out. Please look up. When you get to something like iridium, speak of the devil, iridium has 77 protons, but 115 neutrons. That's not proportional anymore. There's a lot of extras. Everybody okay with that concept? And as we get even bigger, we start to encounter something interesting. Please look up. Why are these fuzzy?
Man-made.
Is that radioactive?
No, because they're man-made. They're synthetic.
Right.
They're not naturally occurring. Somebody had to throw protons at something smaller to make something bigger. These are some sort of accelerator, magic, mumbo jumbo, I don't understand.
By the way, particle accelerators are both protons and electrons.
By the way, these were once named after famous people or famous places, like Neptunium, Plutonium after gods, Americium after America, Curium after Curie, Berkeley after Berkeley Livermore Labs or whatever, Californium because of Einstein, and Fermium and Mendelevium. They never made a Darwinium, and I'm a little bit frustrated. Anyway, eventually they were just like, oh, screw it. And they just started to call them numbers. Like ununilium, which means 110. And then unium, which means 111. And then unubium, which means 112. And I believe we're up to unuventidium now.
We have like 118 or something.
I think we're up to 121. Maybe not. What do I know and what do I care? Here's what's interesting, actually. Here's what's interesting, actually. If we're going to talk about the car analogy, imagine those cars that you see with like metal cages and junk on top that are like riding on the pads all the way floored, kind of wobbly. And I know that a lot of you don't drive, but maybe your mommy and daddy, when they get behind one of these, they move over because those look like a death trap. Like if you were to put one more barrel of random aluminum cans on top, that whole truck is going to break. That's uranium. We'll continue with uranium in a minute. I'd like you to throw down what an atomic number is, what atomic mass is, this proportional thing about the math. And then I'd like you to throw this in somewhere too, uranium. It's 92, 238. And those numbers I think you're going to have to know.
Do you not want us to write down like the C times C11?
Correct.
The number is 238.
Uh-huh, uh-huh, uh-huh. Technically, it's a small fraction more, 0.0289. they made us get out of the car, and we had to wait in this like waiting center, and it was me in my trunks and back sweat, my buddy who mom, just like apologizing for being Assyrian, a whole bunch of people that I understood to be Central American of some sort, and we were all just rapping, and my buddy who mom speaks perfect Spanish, so we were basically just talking to everybody in Spanish. And all those other folks, they were like really worried about immigration status, and we're like, nah, dude, like I own a house, and my buddy who mom is like a businessman, he like manages restaurants and stuff, and like scams Airbnb. So we're like talking to all these fools, and like they were dealing with like serious like life on the line immigration situations, and I remember like the gravity of all that. And then like the guy comes in, and he's got his hand on his like AR-15, and he's got like the vest and all the radios and stuff, and he goes, yeah, they're here. And I was like, oh God, what's gonna happen now? And he goes, copy. And he basically goes, you guys are good, man, just get out of here. I don't know what happened, something about a radioactive dirty bomb or something, and we walk out. And I look back, and like this whole room full of brown people is like, the last thing they heard was, you're good, something about a radioactive dirty bomb. And I was like, bye guys, white privilege. Like, that was such a strange moment. I have so many strange moments. Strange follows me.
You know, like, just casually have a dirty bomb in your car. Seems normal.
They didn't take it, by the way.
Really?
Once they figured out what it was, they wouldn't touch it. They made me climb into the truck, unpack some stuff, get it out of that little side pocket. They're like, yeah, I figured, it was pretty light. And I was like, sorry, man, I didn't know. I apologized to my buddy, like, dude, we're late. I'm sorry, I just wasted so much time. I was like, so what do I do? And they're like, I don't know, bro, you're good. And I was like, do you want to keep this? And they're like, no, just get out of here. So I kept it I had to mail it back to Megan Ball. Uranium is like this crappy old truck with a big aluminum gate full of like bird bats and barrels and wheelbarrows and rusty toolboxes and a washing machine, just like riding on the pads right at that point where if you got any bigger, you would not hold together on Earth, like all these guys. Notice that uranium is right on the edge. Conceptually, that's really critical. When nuclear physicists map the nucleus of uranium, they're like, whoa, that's interesting. If it were one piece bigger, these forces would no longer balance out and it would not hold together. Uranium represents the actually literal maximum of atomic mass that you can have at these temperatures. And you might remember that I told you that isotopes are different numbers of neutrons, which would affect the atomic mass, and that 238 is the average. But here comes something else that you do need in your notes. Uranium occurs in other isotopes. And usually we do this with our isotopes. We just put a number after the symbol. Please look up. Carbon 10, carbon 11, carbon 12, carbon 13, carbon 14, where 12 is average. So 13 is heavy, 14 is very heavy, 11 is light, 10 is very light. Everybody got that? That's just for you to remember how we write the isotope numbers. Now look over here. Uranium has fascinating, mind-boggling, critical concept for the day. The one thing you need to remember, almost all of it is 238. 239 is possible, but very, very rare. 235 is about 0.7 of all the uranium on Earth. And here's the crazy thing. 236 and 237 are not possible. They fall apart. They don't hold together. 238 is perfectly stable. People use that to make crappy toys and like pots and pans. Like uranium-238 is not rare and it's not special. You can dig it up in Summerlin, Carpinteria, Montecito, the Riviera. Uranium is like globally distributed. 238 is just metal. It's heavy. Very, very heavy. Heavier than iron, heavier than lead, heavier than gold. It's very, very heavy. Because, you know, 238 little parts. And 235, there's a little bit of that out there. But let's try something again. Please look up. 236 is inherently unstable. It cannot hold together. I will always, from now on, draw 236 with an asterisk because it only exists for a split second. You can build it and then it'll break. Let me try that again. You can build it and then it'll break. In other words, if you could get one of these and throw a random neutron, you would make something that self-destructs. And when an atom splits, it gives off a lot of energy. That's how we make the steam.
The 236 and 237?
Yeah. I mean, it's 237 is basically, you'll never see this written anywhere ever again because you can't get to that because 236 is unstable. So 237 is utterly forgettable.
How do you get from 238 to 236 without hitting 237?
You kind of don't. Because they don't break off in those parts. They don't break off in those parts. Like, if you were to break something off, it would be smaller than 237 or 237. Like, these shapes are just not possible, so those weaknesses don't exist to chip off a single neutron. Children, let's imagine that I wanted to enrich my experience by teaching just redheads. Okay? Let's imagine, for the sake of conversation, let's just make believe that redheads were sought after.
Some parts of the world.
Does everybody realize that I just pick on redheads because it's kind of a meme, but I think redheads are lovely? Okay.
It's non-racist racism.
Yeah. It's not real racism, it's fake racism. Okay. Children, how can I improve my percentage of redheads in this room?
No, you're a hairball.
Just get rid of everyone else.
Right. I could be 50% redhead if I just dump 33 of you other a-holes. Right? Does that make sense to everybody? That's what uranium enrichment is. Uranium enrichment is getting rid of the useless stuff. You don't actually make more of the good stuff, you just shave off the useless stuff. This classroom becomes more redhead if I can just shave off these fools. And then the class becomes more redhead if I can get rid of these ones. And then our percentage redhead climbs if I get rid of these ones. And then it keeps going up. Now this is, I actually think that this is an interesting detail. This is called fuel. It's been enriched so that 3% is 235. How many of you have heard that Iran is enriching uranium? Maybe you know that there's like this debate about how the international community should manage Iran's enrichment of uranium. Maybe you've heard that the international community is stressed out that Iran could build a nuclear bomb. And Iran says, no, we don't want a bomb, we're just doing this for energy. Here comes all the information that you need. I'll teach you right now the concept of how to enrich uranium. Watch. You take a big chunk of uranium, which is 99.2% useless. You take that big chunk and you grind it up into powder. And you put that in oil and you centrifuge it so that the heaviest stuff goes to the bottom. Right? Then you shave off the bottom, grind it up again, mix it with oil, and spin it. That's why they use centrifuges to enrich uranium. Because you keep spinning the powder and you shave off the heavy, because the light's going to float on top because of centripetal force. Does this all sound credible to you? Please look up. If I can shave off a bunch of this so that this is now like 3%, we call that fuel. That's good enough for a power plant. If I keep enriching to like 90, 95, 98%, now it's nuclear grade, bombs. Enrichment is just the process, and you'll need this, it's vocab. Enrichment is the process of getting rid of the 238 stuff so that the targeted 235 is more common.
So to make a nuclear bomb, you need 97% 235.
I don't know the exact number because there's a lot of different nuclear bombs. I believe that if you're in the 90s, that's weapons grade.
So like it's kind of easy to monitor for making weapons because it's
They're distinctly different product, that's for sure.